Greetings, folks, and welcome to My Mind's Madness. This week on Twitter, as part of my daily CCNA question, I asked my first T-shooter lab. This is meant to be a lab that you go away, download the packet tracer activity file, figure out what's going wrong, come back to Twitter and answer the question poll. The idea of this is to try to prepare you for what you're probably going to come across in the CCNA exam that has now got lab-based questions within it. With that in mind, let's have a look at the lab that we drew up and analyze it a little bit first, and then see if we can figure out what the problem was. Looking at this packet tracer, what we actually have is a very linear path. We have PC1, switch 1, R1, R2, R3, switch 3, PC3. So very linear, quite easy in that sense. Now, I don't know which level you're at in your CCNA studies. You might be just starting out. You may be very close to sitting the test itself. Regardless, I'm always going to try to give as much information for the person who's learning the most at this point in time. I'm not going to go over everything, but I'll try to give as much information as possible. And we're going to firstly look at this network here. Okay, so it covers this interface, these two interfaces on the switch, and this interface on the PC. Now, this network is the 192.168.10.0 network /24. That means it's got a subnet mask of 255.255.255.0. Now, in this network, all of these devices have an IP address, but the two that are important to us right now are the this is .2 address over here, so 192.168.10.2, and this router 1, has the .1 address. Okay, now we're going to move over and we're going to have a look at this side of the network, the green side, as I'm going to call it. Now, this is also a 192 network, but it's 192.168.20.0/24. So again, subnet mask 255.255.255.0. In this one, I've got it that the router's address is .3. That'll make sense in a minute. It's not usual that it's .3, but it'll make sense in a second. And the PC is .1. Okay, so why does that .3 make sense? Well, to understand that, we need to look at how I IP my routers in labs. So firstly, this link here that exists between router 1 and router 2, I have given the IP range 10.1.2.0/24. And on the router 1 end, I give it the IP address of .1. And on the router 2 end, I give it the IP address of .2. This link on the other side of it is the link between router 2 and 3. So I've given it the network 10.2.3.0/24. On router 2 side, it's got a .2 address, and on router 3 side, it's got a .3 address. This is really helpful when you're labbing because you know where routers are purely based on their actual IP address within the network. That being said, we now understand what's going on, and what's happening is when we are trying to send a ping from this PC here all the way through the network to this PC here, something is going wrong. And let's open up the command prompt on PC1 and have a nosy at it. So I'm just going to clear all this away. And PC1. Now, I've already clicked on the desktop icon along the top, and I'm going to the command prompt app. I'm going to pretty much do everything in this command prompt here. I'm not going to worry too much about going to other tabs. This is where I'm going to be. The only other thing I will do after this is look at actual routers, click on them, and pull up the config tab. So, looking at this PC, first of all, let's just confirm its IP address information. So IP config. We can see I've got the IP address of 192.168.10.2, which is correct, and my default gateway is 10.1. Fantastic. Now, what I'm trying to do is I'm trying to ping PC3, which is all the way over in the 192.168.20.0 network and has the IP address 20.1. So I'm going to do a ping-t. Now, what that means is it's going to be an infinite or a timeless ping, okay? And I'm going to go 192.168.20.1 and hit enter. Now, this particular problem takes a little while to show. We're probably going to see about 12 or so pings first before we start to see intermittent successes. Bear with me, I'll speed up the video and we'll watch it happen. We can now see our intermittent pings taking effect. Here's the first one, which it was success. We then add 3 timeouts followed by another successful ping. So we need to analyze this a little bit before we go any further. We had a look at our IP configuration. We know that we're pointing to a gateway. We know that now must be working to an extent because we can actually ping a remote destination. If this was just continuously failing, then it may imply a problem with our default gateway. The fact that we can get there also means that there is a successful path through this network getting to the correct place. But what's happening? Normally when we see something intermittent like this, it would often give us an idea of load balancing, the idea of 2 potential paths that the route could take. And in one instance, it's not getting to the location. In another, it is. But this is a single linear path. How can load balancing be taking effect here? It can't really. A really good option first is to double check though, can we reach our default gateway consistently? So I'm going to cancel this ping with a Control and C. I'm now going to do a ping to my default gateway, 192.168.10.1. Now, this ping comes back successful all 4 round trips. So that doesn't imply any problems between us and our default gateway. But here's a cool piece of logic that not everyone's aware of. If I can ping one interface on a router, I should automatically be able to ping every interface on that router. And here's the logic. If I can get into this router knows where I am and I know where it is. So I can get there. So any other interface that lives on this router that has an IP address knows the way back to me. So I should be able to ping every interface on this router. The only time that that doesn't hold true is when you start getting into access control lists and there are actual things that block that ping from being able to come back to you. So if that's the case, I should be able to ping this interface right here, the opposite side of router 1. So let's try that. We know its address. Ping 10.1.2.1. Press enter. And again, very successful, just as I would expect, but we have now at least taken a point to prove that router 1 isn't really our problem. We are going to have a look at router 1 and its configuration just to determine a few things, but it doesn't look like router 1 is the problem. Now, here's another cool piece of logic. If I can ping this interface, it means I can reach this network. So logically, it means I should be able to ping every address on that network. So it means I must be able to reach this interface over here on the end of R2, which is 10.1.2.2. So let's try pinging that interface and see what happens. Ping 10.1.2.2, and away we go. Sip of tea. Okay, so we now have an interesting element happening. We have a timeout, a success, and a timeout. So we're actually getting close to figuring out where the problem in our network resides. We're seeing that somehow on router 2, something's happening with our requests. How can we figure out what's going on? Well, to do this, we need to have a look at the routing tables of these routers and find out where things are going. Now I'm going to just step away from PC1, and we're now going to have a look at router 1. And I've pulled up the config here. Expand that out a little bit and go into the CLI. Now within the CLI, I'm going to type enable and I'm going to issue the first command, show IP int brief, just to confirm that the IP addresses are what I expect them to be, in which case, yes, 192.168.10.1 and 10.1.2.1. We pinged those already from PC1. We know they're up, we know they're working, but it's always nice to just double check. Next, I'm going to have a look at the root table, so that we can figure out what's going on in the routing table. Show IP root. So looking at this, all of these demonstrate the codes, but our interest starts around here. In fact, one of the things that you often see in the study book is to have something like show IP root and then a pipe begin, or just B for short, and then gateway with a capital G. Now what this means is it just starts the output of that first instance where we see the word gateway. Looking at this routing table, we can see two things that we should know automatically, okay? Our router is directly connected to two networks, okay? And it has an IP address on both of those. So we can see the L codes show us what the IP address of that interface is. In this instance, 10.1.2.1 is the gig 001 interface. Perfect, that's good. The other L is 192.168.10.1. That is the gig 00 interface. So it tells us where that IP address is located thanks to that L code. The second element is the C code. Now this tells us that the network 10.1.2.0/24 can be found because it's connected to the gig 001 network. So again, this is all that logic that I was talking about, just tying in together. And then same over here, this C code is 192.168.10.0/24 can be found out of this interface. So far, everything marries up exactly the way we want it to, just with its physical interfaces. But now let's have a look at this line right here. This is a static route, and it's got an asterisk next to it, which means it's the candidate or the best candidate for a default route, which this is. It is a static route that says 0.0.0.0/0. Now, if you've never come across this, it's basically a catch-all, okay? If this line didn't exist in this table, my router would only know the locations that we've got in the routing table. So the 10.1.2.0 network and the 192.168.10.0 network. If we were trying to get to Google on 8.8.8.8, for example, we don't know where to go, because we only have these two routes in our routing table. So a default route is a fantastic thing that you can use to basically say all other networks that I don't know about that are not in the rest of this routing table, send it out of this interface or send it to this next hop address. So in this instance, we've got a static route that says any other network we don't know about, send it out of gig 001. So we can line that up with what we're seeing here. It's sending it towards router 2 out of gig 001. So we can even see that route actually specified in the interface by just saying show run and then a pipe for section IP route. And here we can see the static route that has been configured on this router. Now, as I said, looks like this is all fine. This is actually a very common style setup for what we call a stub network, a network that lives at the end of somewhere. There's no other way out of this network. It's not as if there's another link over here which could lead to more networks. It's literally a cul-de-sac. You go in one way, you come out the same way, you know? So in this instance, the only other place to find other networks is by sending all our traffic to router 2. This is a very, very acceptable routing table on R1. So already we've eliminated 2 answers as part of the poll. If you said that it was the routes on R1, nope, because we've just figured out these actually look okay. If you answered it's all routes on all routers, you're also out as well. So 2 answers already eliminated. And we're about to go on to router 2 to see if that's where our problem lies. So we can close this one down now and pull up router 2. Okay, I'm going to go into enable and we're going to issue the same series of commands. I'm going to do a show IP int brief and just confirm my interfaces first of all. Let's just span this out a little bit, make it a bit near. So gig 000 is 10.1.2.2, so that's this link that connects to router 1, and that's the interface. And then we've also got 10.2.3.2, which is the link on the other side of this router going off towards router 3. Next, we are going to have a look at the route table. So we're going to do a show IP route. And again, we could do begin gateway, but we're fine, it's all here. And again, we can confirm everything so far with the C and L routes. 10.1.2.0 network is connected to gig 00. That's correct. And 10.2.3 is directly connected to gig 01. That is correct. So we've confirmed that. And now we can see 2 other routes here. We've got 2 static routes. One for 192.168.10.0, and that points out of gig 00, and one for 192.168.00, which also points out of gig 00. And wait, there's more, because there's additional lines underneath both of these routes. So this isn't just one route to each destination. This is actually two routes to 192.168.10.0, and this is two routes to 192.168.20.0. That's not very good in a scenario where we don't want load balancing, where there's only one path. And as you can see, it's actually pointing these in opposite directions. So just to pull my paintbrush back up and have a nosy here, what's happening is traffic is coming in to router 2 from the 10.0 network, and it wants to go to the 20.0 network. So it arrives on the router, and this router, first of all, will turn around and say, okay, looking at my routing table, the 20. Network lives outside the gig 00 network and sends it back towards router 1. If the second ping comes in, I'll draw that in blue, second ping comes in, and the router looks at its routing table, and then this time sends it on towards router 3. So this is why we're getting intermittent routing. It's because sometimes the router's sending it back too early towards router 1, and then in other times it's actually sending it on towards router 3. There is some more interesting information about this, which we'll go to at the end of this video, but let's keep going on and correct this problem. Back to router 2, let's correct the problem. We can issue that same command that we did earlier on router 1, show run pipe for section IP route. Or route. We can see that there are 4 static routes that have been applied here. And what we're going to do is we need to identify which ones are correct and which ones are incorrect. So we're going to focus our attention on the 10.0 network first. We're going to use the output from show IP int brief to determine where that one actually lives. So let's do show IP int brief again, just to pull it up. So gig 00 is the interface that goes towards router 1. So if I'm looking for 192.168.10.0, I should be going out of gig 00, not gig 01. So the highlighted line, I need to remove that. So let's do that. Conf t, or configure terminal, and I'm going to issue the command no. And to make this really, really nice and sweet, what I'm actually going to do is I'm going to copy the line that I don't want. Okay, copy. And then I'm just going to hit paste. So now I've got no, and I've just pasted that entire line in, and I can press enter. And that line is removed. We can even have a look. I'm going to show you another command here, which is the do command. Because if I do the exact same command, show run pipe for section IP route, it's going to come back saying, I have no idea what you want me to do. And that's because we're in configuration mode. It doesn't understand show commands at this level. But one command it does understand is the do command. So if I press up to recycle that command back into my prompts, show run section IP route, and then press Control and A on my keyboard, I can now put the word do in front with a space and press enter. And there we go. I can now see the IP route again. And in this instance, we can now see that the erroneous one's been removed and we're only left with the gig 00. So now we also need to do exactly the same. So we need to get rid of IP route 192.168.20.0 out of gig 000, because that's pointing us down here, which isn't right. So I'm going to copy that and I'm going to paste it. Oh, it's actually taken that one again. Oh no, because I copied the entire line with a carriage return captured. So it's pasted that in. Not to worry though, all it's actually done is just overwrite the line. If I do show IP route again, nothing has changed because I've just pasted in a line that already exists. So what I will do is I'll press up to recycle that IP route command, Control A again, and put my no space in front of it. And there we go, that line's removed. Do show run to confirm. Yay, now we have a route to the 20 network going out of gig 001 and a route to the 10 network going out of gig 000. Fantastic. We found a problem. We fixed it. Let's see what impact that has on our route. So we are going to do another ping -t towards 192.168.20.1. Straight away, we can see we are getting successful pings pretty fast. There's no intermittent routing happening here. So from the looks of things, we have determined that the problem was with router 2, but we wouldn't be doing our due diligence if we didn't check router 3 as well. It's always worth doing. There may be something else in play. Remember, when we first started looking at this, there were a good few failures before there was even the first success. So it's worthwhile looking at R3 just to be safe. So let's have a look at R3. We're just going to issue the same commands. Full screen this one for some reason. Enable, and we'll do a show IP int brief. Helps when I can spell it right. We can see our interfaces there. Gig00 is the 192 interface, that's correct. And Gig01 is the link between router 3 and router 2. So that's good. Show IP routes. We've got a very similar routing table looking similar to that of router 1, where you have your standard routes, which are your connected and local IPs. And then we also have a static route pointing everything out of Gig01, which is the link that goes towards router 2. So in this instance, router 3 is configured exactly the same way as router 1 was, just pointing in the opposite direction. And again, show run pipe for section IP routes. We can see it's configured pretty much the same way, again, just pointing out of a slightly different interface towards R2 as opposed to pointing from R1 to R2. So in this instance, R3 is not a problem. But now let's talk about what's actually happening and another cool thing. So I'm going to pull my pen up again and we're going to have a real assessment of this particular network. What we had when this was broken was one ping would come in here and go into the router in R1. This would use a default route to send the unknown destination of 192.168.20.0 up to R2. So it's using that default route to do this. Now, in this instance, R2 looks at the destination, says 192.168.20.0, and when we had the erroneous routes in there, it would have turned around and said, okay, send that back towards R1. Now it would reach R1. R1 looks at its routing table and would say 192.168.20.0. That should use the default route. And then it would send that route back up. And if you've not noticed already, what we've created here is a loop between these two routers. So we've got this little loop happening. Now, what's interesting is picking up from where we're leaving the second time coming out of R1, okay, we are going to get into R2 this time as a second packet, and this one's going to say, oh, I'm going to send this off towards R3 this time. So then it sends it off towards R3. R3 sees 192.168.20.1 and sends it into the LAN towards the PC. So hey, oh, presto, we've finally reached the destination. Now let's have a look at the return path because it's going to be very similar. It comes from PC3 into R3. R3 looks at its default gateway, or sorry, its default route, and decides that to get back to 192.168.10.0 network, it should send a packet up towards router 2. Router 2 looks at this packet, may determine that this needs to go back down towards R3, which it does, which again looks at its network and says, I need to send this all the way back up to R2, and we've got another loop. Finally, we get into this router again, and now we're getting sent down towards R1, and we finally get to our destination. So this is why we're seeing intermittent packets, because in some instances, a packet is getting looped around till the time to live dies, okay? But that can happen, or alternatively, there are instances where we might just happen to catch R2 in a good moment, and that packet gets sent straight through correctly. And that's probably the one that is successful. The rest are probably dying thanks to the TTL value that's held inside of a packet. So folks, I really hope you enjoyed this walkthrough of this T-shooter. If you have any questions about it, feel free to reach out on Twitter, on YouTube, whatever you want to do. Just try to get a hold of us. Feel free to visit our website, mymindsmadness.com. Links are wherever links go in this kind of scenario. And yeah, please feel free. How can we make these things better? How can we do better for you to get towards your CCNA? All the best, folks.